All right, y'all. So we're going to look at using inverse or using the calculator to solve these inverse trig questions. So the first half of this is just button pressing on a calculator. You want to make sure that you do give your answers in both degrees and in radians. And so it's just making sure that you can evaluate it using the calculator. So for example, if we're trying to do number 1, you would do secant inverse on your calculator and then type in your negative 2.3 and then press enter. You would want to make sure that you check your mode. My mode right now is in degree mode, so my answer to 3 decimal places would be 115.771 for number 1. And then if I were you, I would do them all in degrees first and then go back, change your calculator to radians. To change it to radians, you would go to, from the home screen, you would have to go to your document settings and change those settings, or you could toggle here, and when you click on it, you can change it to radians that way. On mine, I just click the button and it changes. So y'all's, you've got to go press some different numbers to get it changed into radian mode. But you can click on that little settings wheel there and click down and see where you can get to radians. And so then you would just type the same thing again, your secant inverse of negative 2.3, and then press enter, and you'll notice that you get a completely different answer. In radians, it would be 2.02, and then it would be 1 because that 5 would round that 0 to a 1. So make sure that you finish 2 through 9 on your own. It's just button pressing on those. Super simple, straightforward. It's just, it takes time to do it, okay? So this video is going to focus more on solving using your calculator, okay? So remember from yesterday that when we're trying to solve an equation for theta, okay, we have to use our inverse trig functions. And so when we're looking at this, if we're trying to find sine of theta, so if we're trying to find theta when sine of theta equals negative 0.2678, we must find that reference angle first, okay? We do not put the sign in when we do that. The sign is going to tell you what quadrant it's in, and by sign there, the SIGN, okay? So when we think about this, sine is negative in quadrants 3 and 4. Okay, so what that means is, that means that we've got 2 options for our theta, where theta could be. Okay, so our reference angles would be here, so that would be theta, or that could be theta, or here. So there would be your reference angles because sine is negative in quadrants 3 and quadrants 4. Okay, so then in order to actually evaluate it, and we need our answers to be between 0 and 360, so we know we're in one rotation, we're going to use our calculator so that we can find theta prime, okay? So in order to, what we're going to do is we're going to do sine inverse. In your calculator, do sine inverse of 0.2678. Notice you do not put the reference angle in there. Okay, I mean the negative sign in there. So we're doing sine inverse of 0.2678. So give me a second so y'all can actually see that. Oh, let me make sure this is in the correct mode. I need this back in degree mode because we're from 0 to 360 this time. So we're going to do sine inverse of 0.26778. And that gives us 15.5333, okay? So what that means is that 15.533 is the measure of your reference angle, okay? So that means that this would be 15.533, and it means this would be 15.533, okay? So when we do sine inverse, that's going to give us our reference angle, or theta prime. To finish out getting your answer, you've got to use the fact that you're in quadrants 3 and 4. So the theta prime in quadrant 3, so in quadrant 3, our theta is going to equal 180 plus the 15.533 because you're in quadrant 3, which is 195.533. Quadrant 4's angle, so if we're in quadrant 4, our theta, the easiest way to do it is think of that as that is 360 minus your reference angle, because it's everything except this little chunk here. And so when you do 360 minus 15.533, you get 344.47. So you have to know what quadrant you're in, and then you've got to think about whether you would add that reference angle to it or subtract that reference angle from it, okay? So now we're going to focus in radian mode. So take a second and get your calculators back in radian mode. I'm going to get mine back in radian mode so that I don't make a careless mistake. All right, so if we are going to do cosine of theta equals negative 0.9321, and we have to first figure out what quadrants are cosine negative in. So when I sketch my picture, you've got your coordinate plane. We know that cosine values are negative in both quadrants 2 and 3. Okay, so we're looking at this angle or this angle. So those are our two angles. And whenever you do cosine inverse of 0.9321, that's going to be your first step, is to use your calculator to do cosine inverse of 0.9321. You should get 0.371. So that means that this value in here is 0.371, as is this value in here. Now be careful, because this time we're not working from 0 to 360. This time we're working in radians. So just to remind you, in radians you're at 0, and then over here is pi, and then back over here is back to 2 pi. So when we go to simplify, or whenever we go to find our actual theta, our theta in quadrant 2 is, let me get my notation correct, in quadrant 2, our theta would end up equaling pi minus your reference angle of 0.371, because you need everything except that chunk. So this would be pi, all the way across would be pi. We need to subtract off that 0.371, and so that would end up giving us 2.771. And then your angle, if you are in quadrant 3, your angle theta would end up being pi plus 0.371, because you've gone a half of a rotation plus that much more. And so that would end up giving you 3.513. So it's all about making sure that you know where things are positive and where things are negative, and then it's the same process, you just have your calculator. So just to refresh your memory, when we're talking about where things are positive and where things are negative, you can remember all students take calculus. Everything's positive in quadrant 1, just your sine and sine's partner function cosecant. So this would be your sine and your cosecant are positive there. Tangent and cotangent down there in quadrant 3. And then we have cosine and secant in quadrant 4 that are positive. All right, so one more quickly together, and then I'm going to let you do number 3 by yourself. Cotangent would be positive. So notice this time it's positive. Cotangent would be positive in quadrant 1, because everything's positive in quadrant 1. And again in quadrant 3. So this time your reference angle is in quadrant 1 and in quadrant 3. So then we need to figure out what our reference angle equals. And so our reference angle, theta prime, would equal cotangent inverse of 5.921. And that should give you a value of 0.167. All right, so in quadrant 1, your theta prime is your theta. So in quadrant 1, theta would just be 0.167, because that is the value there. There's no reason to add or subtract it, because we're going from the 0 up to there. Now in quadrant 3, we do have to add something to that. So in quadrant 3, our theta is going to equal pi plus that value, because we're more than halfway around that circle. So remember, pi would be here at your halfway mark, and then you would add that 0.167 to it for a value of 3.309. So I want you to complete number 3, just so that you can check to make sure you have your correct answers. When you finish number 3, your two theta values should be 1.939 and 4.345.